Assalamualaikum to my lecturer and fellow friend. Today we are about to present regarding to the topic to the higher combustion engine efficiency homogeneous charge compression ignition engine HCCI versus variable compression ratio engine. First, we need to define what is the difference between both engine clearly. Let's go with the HCCI first. HCCI engine is a hybrid of spark ignition and compression ignition diesel engines with the objective of potentially hastening both advantages in single setting. Furthermore, the HCCI engine technique is the process by which a homogeneous mixture of air and fuel is compressed until auto ignition occurs near the end of the compression stroke, followed by a combustion process that is significantly faster, either compression ignition or spark ignition combustion. HCCI technology claims to increase the thermal efficiency of the engine while retaining low emission and can be introduced by altering either HCCI or by altering either CI or CI engine using any combination of fuel. Besides, one primary characteristic affecting thermal efficiency is the compression ratio, which is often a compromise in spark ignition engine with fixed compression ratio. So that the VC concept, which is VC engine concept, promises enhanced engine performance, efficiency and reduced emission. Due to the higher compression ratio, the higher cylinder pressures and temperatures during the early part of the combustion and small residual gas fraction give faster laminar flame speed. Hence, the ignition delay period become shorter. As a result, the higher the compression ratio, the shorter the combustion times as it at low loads. Means that it can give a higher compression, it can give higher thermal efficiency. That's all. Thank you.
Next slide is working principle and methodology.
Hello everyone and welcome. My name is Faizal. In this video, we will be talking about the HCCI engine. The first two terms in the HCCI engine is the homogeneous charge, which is referred to the good mixture of air and fuel rather than stratified like the diesel engine, and the last two terms is compression ignition, using the compression to ignite the air-fuel mixture rather than spark ignition, unlike you have with traditional gasoline engine. Okay, looking at the difference between SI, CI, and HCCI engine with a very similar four-stroke. For SI engine, the air-fuel mixture is ignited by using spark plug, and the flame front travel outward from the spark plug. Same goes to the CI engine, the flame front form when fuel is injected. Both conditions will cause high production of nitrogen oxide. For HCCI engine, the air and fuel mixture is pulled in and compressed in. Instead of having an ignition source, the idea is to have all the mixture to simultaneously combust as the piston compress it. So it's not going to have the flame front traveling out, and the advantage for not having flame front is that you are not going to create the nitrogen oxide. The flame front will have hotter region, and hot region will produce more nitrogen oxide, and so HCCI engine will run much cooler internally, and as a result you will not have peak temperature and you won't have the nitrogen emission. Another thing that I need to add is the chart. As we know, SI engine have a very cleaner emission but low fuel efficiency, while the CI engine have high fuel efficiency but produce not a very clean emission. So HCCI is kind of the best of the both. So advantage of the HCCI is produce lower nitrogen oxide emission caused by lower internal combustion temperature. It is also more efficient than SI engine, as the HCCI engine do not have pumping losses, use higher compression ratio, and using slightly linear air-fuel ratio in order to maximize the fuel efficiency.
Variable compression ratio engine is the technology to adjust the compression ratio of an internal combustion engine while the engine is in operation. An engine compression ratio is a fundamental choice made when designing an engine. It's defined by the volume ratio from top dead center to bottom dead center. Typical values of CR in modern spark ignition engine range from 8 to 1 on the low end to 12 to 1 or on the high end. The engine designer considers factors such as performance and efficiency goal, fuel type, fuel quality, and level of boost pressure. A higher compression ratio is advantageous. However, high compression ratios throughout all operating range create unfortunate consequences such as a knock at low load conditions. Next is a VCR mechanism. The details of the CR varying concept play a large role in the performance of the VCR engine. CR Astana made the most recent organization of design using 6 categories of the design concept. First is a moving cylinder head. Next is changing the crankshaft axis, changing the geometry of the connecting rod, moving the piston crown relative to the piston pin axis, dual piston mechanism, and lastly gear-based mechanism. The figure shows how brake mean effective pressure is affected by change in compression ratio in SI engine. Generally, the higher the CR, the more Bmax can be achieved. However, it can be seen that for values of CR above more than 11, the effect seems to be counterproductive. This is due to the fact that spark is advanced and therefore the compression ratio at spark is lower than intended. Next is a methods to achieve VCR. Firstly is a named SVC, SAAB variable compression. It's cleverer than any previous pattern for variable compression ratio engine because it involves no additional moving parts at the combustion chamber or any reciprocating components. So in theory it's simple, durable and free of leakage. The monohead itself contains, that means it has its own cooling system, cooling passage across the head and cylinder wall. Connecting rod linkage. A popular approach has been developed to replace the conventional con rod with a two-piece design, which in an upper member connects with the piston while a lower member connects with the crankshaft. The shorter crank throws allow room for the link system, as shown in figure, which is anchored by an eccentric rotary actuator.
For working calculation, that will explained by me, Muhammad Iqbal Hafizi, with metric number B0416100204. For homogeneous charge compression ignition engine (HCCI), the combustion efficiency is calculated using measure engine emission as the combustion efficiency equal to 100 minus 100 times MHC LHVF plus MCO LHVCO over MF LHVF, where MHC and MCO are the measured ambient hydrocarbon and carbon oxide masses respectively in the exhaust. The parameter LHVCO is the lower heating value of CO. Accurate emission measurement for world engine operates range in time consuming difficult. That's tell by Charles and Koch in 2016. The combustion efficiency is calculated as the combustion efficiency equals to 100 times QHR over MF LHVF. For variable compression ratio engine (VC engine), an engine compression ratio is a fundamental choice made when designing an engine and is defined by the volume ratio from top dead center to bottom dead center (BDC). The research have been done by Kalbifish and Darbani in 2018. Both SI and CI cycles thermal efficiency increase with compression ratio. The freedom to change the CR allows for the engine to maintain a more optimal CR for all operating conditions. The research has been made by Kalbifish and Darbani in 2018. There are two ways to find the efficiency. Efficiency equals to 1 minus 1 over CR to the power of K minus 1. K is stand for specific heat ratio. Efficiency, the second one to find the efficiency is efficiency equals to 1 minus 1 over CR to the power of K minus 1 times CR K to the power of K minus 1 divided by K in bracket RC minus 1. RC is stand for cut-off ratio. There are the effects of VCR on specific fuel consumption. First, brake specific fuel consumption is directly related to the thermal efficiency, which is governed by the change of CR. As the CR is increased, the efficiency also increases. It's also reducing the fuel consumption. That has been told by Kalvish and Darbani in 2018.
Okay, for the conclusion, it is proof that HCCI technology can increase the thermal efficiency of the engine while retaining low emissions. The system features lower temperature combustion compared to ordinary gasoline engines, resulting in nearly no NOx emissions. Hence, high engine performance can be achieved with low NOx and soot emissions. Besides, HCCI engine offers many advantages as the engine is a hybrid of SI and CI engines, which can harness both advantages in a single setting. HCCI engines offer fuel flexibility since the technology is the combination of the SI and CI engine. It means that wide variety of fuels can be used in order to operate the engine. Due to the high compression ratio capability and quick combustion of HCCI engine, it produces higher efficiency compared to SI engines, which approaching the efficiency of CI engines. In addition, low levels of smoke and particulate matters emission can be harnessed by using this type of technology, as the engine ensures smoke reduction and discourages the formation of soot. Other than SCCI engine, variable compression ratio or VC engine can also enhance the engine performance, efficiency and reduce the emissions. This type of engine can give faster laminar speed due to the high compression ratio, which can lead to the higher cylinder pressures and temperatures during the early part of the combustion. As a result, the higher the compression ratio, the shorter the combustion time as the ignition delay period becomes shorter. Besides, VC engine offers low fuel consumption as well as low exhaust emission. Furthermore, VC engine can work at various compression ratio depending on vehicle performance needs by adjusting the volume of the combustion chamber. Hence, it is clear that HCCI engine and VC engine have contribute convenient benefits in internal combustion engines application, which offer the better engine performance.